So what me and Jacob are reviewing are tides. What is a tide? Tides are very long period waves that move through the ocean in response to the forces exerted by the moon and sun. They originate in the oceans and progress towards the coastlines where they appear as the regular rise and fall of the sea surface. How do tides work? They are caused by the gravitational pulls of the moon and sun. So imagine the ocean is shaped like an oval pointing at the moon. The oval's pointed ends represent the parts of the earth experiencing high tides, and the oval's flat sides are the parts of the earth experiencing low tides. The point facing the moon is formed because the gravitational pull of the moon is strongest on whichever side of the earth faces it. Gravity pulls the ocean towards the moon and high tides occur. The water moving away from the moon resists the gravitational forces that attempt to pull it in opposite direction. Because of the gravitational pull of the moon, it's weaker on the far side of the earth. Inertia wins the ocean bulges out and high tides occur. As the earth spins, different areas of the planet face the moon, and this rotation causes the tides to cycle around the planet. Sir Isaac Newton. In 1687, Sir Isaac Newton explained tides have to do with gravity. Newton's law of universal gravitation states that the gravitational attraction between two bodies is directly proportional to their masses. The greater mass and the closer they are, the greater the gravitational pull is. So there's 3 different types of tides, and they're seen as the diurnal, which is 1 high and 1 low tide each day, semidiurnal, which is 2 high and 2 low tides each day, and mixed, which are 2 high and 2 low tides each day of different heights. Diurnal tides occur when there is a lot of inference by continents. Only 1 high tide and 1 low tide occur per day. In the Americas, diurnal tides only occur in the Gulf of Mexico and the coast of Alaska. Semidiurnal tides are 2 equal high tides and 2 low tides each day. They happen in the eastern coast of North America. They have a period of 12 hours and 25 minutes. If the whole globe was water, everywhere would have a semidiurnal tide.
So there's also mixed tides, which are 2 unequal high and low tides that happen each lunar day. This only happens on the western coast of North America and the eastern coast of Asia and a few other places. It's not as common though. That's a map that shows the different areas that have the different types of tides. If all the continents were, if there was no continents and it was only water, then everywhere would have semidiurnal tides. So there's spring and neap tides. Those are separate from the other tides we just went over. Has to do with the position of the sun and the moon. So spring and neap tides are different types of tides based on the position of the sun and its phase. Both occur twice a month, and it depends on the relationship between the moon and the sun. A spring tide, so it actually has nothing to do with the spring season. It refers to the springing forth of the tide during a new or full moon. A new or full moon is when the earth, sun, and the moon are aligned or generally aligned, and this causes the high tide to be much bigger and the low tide to be much smaller because of the added gravity from the sun. A neap tide, it happens 7 days after the spring tide. This is because the moon and the sun are at a right angle to each other after the full or new moon passes. The gravitational pull of the sun is canceled out by the pull of the moon and makes the low tides higher than the normal and the high tides lower than it normally is. This appears when the moon is half full or the first and third quarter moon. So this is a picture of each of them. So on the left is the spring tide, so you can see that the moon and the sun are lined up with the earth. So the extra gravity of the sun and the moon make the high tide stronger than it is when it's the other tide. So you can see that the moon is at a right angle to the sun, so the gravity kind of cancels each other's out and makes it more of a sphere instead of like an oval. And that's our bibliography.